We're going to learn about chemical reactions today and kind of piggyback on what we just finished up in Chapter 9 with chemical formulas. So we're going to talk about how to represent chemical equations and how to balance those today. Also going to talk about some of the symbols that we see in our chemical equations. This is Chapter 11, Chemical Reactions. When we write a chemical equation, it's much like what we do when we write sentences in English. Like if you think about the letters of the alphabet, we put those letters together to make words, and then we put those words together to make sentences, and that's our language that we use to communicate. Well, a chemist takes those symbols from the periodic table, those are like our alphabet, we put those together in the correct ratios, of course, and we make words, which are our chemical formulas, and then we can put those words together to represent a chemical reaction in a chemical equation. So there's three requirements of all chemical equations. First of all, they must represent known facts. There must be reactions that are known to occur. And the second thing is they must contain correct formulas of their products and their reactants. So that's what we spent the entire Chapter 9 learning about, is how to write the formulas correctly for ionic compounds, how to represent our polyatomic ions correctly, how to write formulas for our molecular compounds as well as our acids. The third requirement that a chemical equation must satisfy is it must satisfy the law of conservation of matter, which means, remember, matter can neither be created nor destroyed in a chemical reaction. We do this by balancing the equation. That way we make sure that all the atoms that we started with are equal to all the total atoms that we produced when the reaction occurred. Now there are some symbols that we're going to see, so I want you to be familiar with what they represent. So the symbols that we're going to talk about here, you see here on the left-hand side of the screen. So let's talk about what each one means. The first symbol is a forward arrow with the arrow pointing towards the right. This is called the yields sign. This is the symbol that separates your reactants from your products. You can also use this symbol in our chemical reactions in the same place you would use your yield sign, but this represents what we call a reversible reaction or a chemical equilibrium. Notice that you have two parallel lines with arrows pointing in opposite directions. So this represents chemical equilibrium, which is very, very stable. The next four symbols are symbols that we use to represent our state of matter, or also here we see AQ, which means the substance has been dissolved in water. So if we wanted to represent something was a solid, we would put a lowercase s in parentheses, like a subscript, beside the formula. This does not affect how you balance the equation. It's just giving you more information. So this is representing ice, so water in its frozen state. If we want to represent a liquid, H2O, with an L beside of it as a subscript again. Remember, you want to make sure these are written as subscripts. You don't want to misinterpret that as potentially like a Roman numeral. So I oftentimes will write that with a cursive lowercase l. Now, I failed to speak about this arrow here, so let me go back up to the solid and talk about this. This is an older way to represent something as a solid. And so if you were to use the arrow pointing down, you would put the formula H2O, but you would write an arrow beside it pointing down, and that represents a solid. So if you think about it, most solids are going to be very dense, and so if you were to think about, take a pen or a pencil, and you dropped it, it's going to fall down due to gravity. So we put an arrow pointing down for solids. We saw this symbol when we talked about our acids. It's AQ, and it stands for aqueous. Now what aqueous means is that the substance has been dissolved in water. So you can see this symbol used many, many different ways, or with many types of compounds rather. So here I wrote it with the formula for table salt. So when you see NaCl with an AQ beside of it, that means that the salt has been dissolved in water, so you have a saltwater solution. Finally, If you want to represent a gas, you can use a G or an arrow pointing up because most gases tend to rise. So here you see O2 with a G, means oxygen gas. Or if you wrote it with the arrow, you would put O2, put your formula, and you would put the arrow pointing up beside of it, indicating that gases tend to rise. They tend to be less dense. All right. There are also some symbols that you see written over the yield sign. So I'm going to show you 4 different symbols here that you will see written over your yields or even your equilibrium sign. And they represent or indicate conditions at which the reaction was carried out. So first one you see here is going to be a triangle. This triangle is otherwise known as a delta. And when you see it written in this position or in this place over the yield sign, it means that heat was added to the reaction as it occurred. So it did not just occur at room temperature. Now, if you wanted to be even more specific, you could indicate the specific temperature. So here I just chose 0 degrees Celsius, and that would give you insight into specific conditions that were taking place during the reaction. So obviously, if you were carrying a reaction out at 0 degrees Celsius, it would affect the rate of the reaction. Typically, your reactions are going to go a lot slower in colder conditions and faster in hotter conditions or warmer conditions. If you change the pressure, you could put a specific pressure over the yield sign. Here I've chosen 2 atmospheres. Normal atmospheric pressure is around 1 atmosphere at sea level. So if you were to see 2 atmospheres here, then you would know that they had pressurized the reaction as it was taking place. And that would obviously affect the outcome, affect the conditions at which the reaction was taking place. Finally, if you add a catalyst to the chemical reaction, you would put the symbol for the catalyst over the yield sign because a catalyst is not a reactant nor is it a product. So we write it over the yield sign because it itself is not changed during the reaction. Its only function is to speed the reaction up and make the reaction go faster. So if a catalyst was added, you would put the symbol for the catalyst over the yield sign. Specifically here, this is platinum being used as a catalyst. There are many catalysts you can use in a chemical reaction, so you're not just going to see PT. If I were to tell you that the permanganate ion was used as a catalyst, you would put over the yield sign the formula for permanganate ion, which if you recall from our polyatomic ions is MnO4 with a -1 charge. This would represent permanganate ion used as a catalyst. Remember, your reactants always go on this side of the yield sign, and the products would always go on the right-hand side of the yield sign. So if you see a formula for something written over the yield sign, that means that substance is a catalyst in the reaction, so it would speed the reaction up. Next, we're going to look at balancing equations, and a couple of things I want to just suggest is I would always balance equations in pencil because it is a trial and error process. When you're balancing equations, you're going to be balancing the number of atoms or molecules present. You never, ever, ever want to change your subscripts. Do not change your formula. You're only going to, you're going to balance simply by putting coefficients. So remember, coefficients come at the beginning. So like going back to algebra, if you were to see 4x cubed, we would call the 4 the coefficient, and the x would be your variable. Well, in a chemical reaction, where I've got the x here would be where your formula would be. So like if you were balancing and you wanted to have 2 sodium chlorides, then you would put a 2 in front as your coefficient, and that would mean you had 2 sodiums and 2 chlorines. You distribute like 2 times the 1 gives you 2 sodiums, 2 times the 1 chlorine gives you 2 chlorines. So let's look at some equations to balance. The first one that we see here is representing the decomposition of mercury to oxide. Notice they're heating it here. There's one of our symbols, and we see our states of matter represented as well. There are 3 places you can put a coefficient. I'm just going to put a little dash there. I don't see anything complicated looking about this one, so I'm just going to start here and go back and forth till I get it all balanced. I see right now I have